Hello everyone, I welcome you all for the video lecture on data structures. The topic to be discussed is abstract data types. What is an ADT? ADT stands for abstract data type. It is a mathematical model of a data structure. It defines data and operations on data. It hides implementation details from users. How can we define ADT? An ADT specifies what operations can be performed, but not how they are implemented. Let us empathize this concept. So, understanding the user's needs, challenges, and expectations, we need to identify the requirements of programmers, understand the operations needed. For example, a stack ADT, the operations of stack ADT are push, pop, and peek. Let us define clearly. We need to state the problem to be solved. Then we need to determine the behavior of the data structure. Then we need to specify the functional requirements. Example, design a stack ADT that follows last in first out principles. And then in the ideal phase, let us brainstorm and generate multiple ideas. So explore different implementation methods, compare the alternatives, and the example goes like array-based stack, linked list-based stack. Prototype phase. Here we create a model or preliminary implementation. For ADT, we need to develop the ADT operations. For example, push, pop, peek is empty. Characteristics of ADT. An ADT type is a logical model that defines a set of data and the operations that can be performed on the data without specifying how these operations are implemented. Abstraction. ADT shows only essential information and hides unnecessary implementation details. Encapsulation. Data and operations are bundled together as a single unit. Users interact only through defined operations. Information hiding. Internal representation and implementation details are hidden from the user. Modularity. Another characteristic of ADT, which means ADT promotes a modular approach to program design. Each ADT is independent and self-contained. Reusability. ADTs can be reused in different programs without changing their implementation. Implementation independence. The implementation of an ADT can be changed without affecting the user programs that uses it. Components of ADT are data and operations. Data, the information that we store, and operations, functions that can be performed on data. Example, stack ADT. The operations of stack ADT are push, pop, peek, and SMT. Let us differentiate ADT and data structure. The logical view is called an ADT, and physical implementation is what we refer to the data structure. So in ADT, we refer what operations are performed, and in data structure, how the operations are implemented. And ADT is independent of implementation. Data structure depends on implementation. Example of ADT, stack. Data structure examples are array, linked list. Common abstract data types include list ADT, stack ADT, queue, tree, graphs, set, and dictionary. List ADT operations are insert, delete, search, update, traverse. The implementation is by arrays, linked list. The applications are student records, contact list, etc. Then stack ADT, the principle behind this is LIFO. It means last in, first out. The operations are push, pop, peek, and SMT. Examples are push the element 10, push the element 20, and pop element 20. Applications of stack are function calls and operations, expression evaluation. In Queue ADT, the principle is FIFO, that is, first in, first out. All operations are in queue, TQ, front, and rear. The applications of Queue ADT are CPU scheduling, printer queue, and ticket booking systems. Advantages of ADT are it simplifies program design, it promotes code reuse, it is easy to debug, it is better providing you security through abstraction, and it is independent of implementation. The disadvantages of ADT: additional design complexity, slight overhead, learning curve for beginners, performance depends on implementation. Applications of ADT: database systems, operating systems, compiler design, artificial intelligence, and networking, and in software development. Thank you.